Today we're discussing 9.3, which is properties of logarithms. And this is how we're going to learn a lot of the properties on how to solve logarithms and to be able to rewrite things. So when there are multiples, you might have 2, 3, 4 logarithms on one side. You can rewrite them to just make one so you can eliminate the logarithm totally. So the first one here is the product property of logarithms. And what it says is the logarithm of a product is the sum of the logarithms of its factors. So notice you have the logarithm of m times n. What you do is you separate that so it's the same base, but you add them. So just like we did with exponentials, if you raise two things to the same, if you have two same bases and you multiply them, you add the exponents. Same thing here, when you're multiplying inside the logarithm, you add those two logarithms. So let me show you one example of this. We want to approximate the value of log base 2 to the 48th, or of the 48th. So what I do here is I can rewrite log base 2 of 48, and I want to try to rewrite this as the log of something with the 3 in it. So if I rewrite this as log base 2 of, now something with a 3 times something, well 3 times 16 gives me 48. Okay, so whatever they give you, they're going to give you some approximation. You're going to use that, and then I have the 16 left over. What that tells me is that I can say log base 2 of 3 plus log base 2 of 16. So now I know what the log base 2 of 3 is. This is 1.5850. But I want to be able to add that to whatever this is. So what I'm going to do with this one is if you match the base to the piece inside. So 16 is 2 to the 4th power. If these are the same, they're going to cancel and you're just going to be left with this one. So this becomes 1.5850 plus 4. So my final answer is 5.5850. So again, like this, if I have log base something, so let's say I had log base 4 of 64. That's log base 4 of 4 to the 3rd power. If the base and this number match, if your two bases match, those all cancel and you're just left with whatever that exponent was. So that's what I did here to get rid of that and to get the 4. And they gave me this one. So all we did was break this up into a product, and that product broke up into the addition of two separate logarithms. Similarly, when you're dividing two, so if I can do two things divided by one another, then we're looking at subtraction. So the logarithm of a quotient is equal to the difference of the two different logarithms. So there we had the log of m divided by n, and then we made that the log of m minus the log of n. So again, this time they give us two different ones. And we want to approximate log base 3 of 4. So we're looking at the log base 3 of 4. Well, how can I write? So they give us information for 5 and 20. So this might be pretty obvious how you can get to 4. That's going to be the log base 3 of 20 divided by 5. Because 20 divided by 5 is 4. All I'm doing is writing this as a division problem of the two numbers that they gave me. So now what I say is log base 3 of 20 minus log base 3 of 5. So I took this number, I made it into a division problem, because 20 divided by 5 is 4, and then this division becomes subtraction of two different logarithms. So now I say log base 3 of 20, we know is 2.7268, minus log base 3 of 5 is 1.4650. And when I subtract those, we end up with, let's see, where am I here? 1.2618. And the final property, so we just have these three properties on how we can use these things to rewrite logarithms. And these are the same three properties we're going to use for the rest of the chapter. So the next property tells us if we have a power property. So inside, if you have a power, so we have m to the p power, that power can go out front of the entire logarithm. Or if you have something on the inside, or on the outside, if you have p times the logarithm, you can put that as the power of what's on the inside. So these work both ways. So again, let me show you an example of how exactly this is working. Now they give us log base 4 of 6. So I want to take log base 4 of 36 and somehow rewrite that with log base 4 of 6. So they're kind of telling me what you want to use and what you want to get to. So I can rewrite this as the log base 4 of 6 squared. Okay? So I take 36 and I rewrite it as 6 squared. That's all I'm doing. Log base 4 of 6 squared, that squared comes out front. So we have 2 times log base 4 of 6. Now I know the log base 4 of 6 is 1.2925. When I multiply that, we end up getting 2.5850. So all of these are kind of building to the idea that we can use these logarithms to solve logarithmic equations. So what I'm going to do is I'm going to take this and I'm going to use these logarithm properties, and really this time we're going to have to go backwards of them because they're giving us things with numbers out front, we're subtracting, and we somehow want to get to be able to solve this. So we're going to go piece by piece by piece. We're going to use these properties to solve this equation. So the first thing, I'm going to pull this out just so we can see it a little more clearly. We are looking for this x value. Okay, so you want to identify where the variable is and what we're looking for. Now they don't give us any approximation, so we have to use logarithm properties to try to eliminate some of this. This 3, remember, it's out front, so that can become the exponent just of this logarithm, not the whole thing. Okay? And you also want to think about PEMDAS, the order of operations. Don't do subtraction first, deal with multiplication, the exponents, deal with those things first. So this becomes log base 5 of x cubed minus log base 5 of 4 is equal to log base 5 of 16. Okay, so the only thing I changed was made this the exponent. Now the subtraction means division. So I can rewrite this as one property. We have one logarithm. X to the third divided by 4 is equal to log base 5 of 16. So when I'm subtracting two things, I don't write this as 2 logs divided. I write it as the log of x cubed divided by 4. Okay, don't write the logarithm twice. You only write it once. Now, the same logarithm on both sides, we talked about this before, you can cancel those. So I end up with x to the third over 4 is equal to 16. Multiply both sides by 4, we get x cubed is equal to 64. The cube root of 64, x is equal to 4. And that's how you use logarithm properties to solve logarithmic equations. So you guys need to become very, very familiar with these things. For some reason or other, every year these create issues for people. So you definitely want to study these, memorize them, really, really learn them so that you can get a good handle on how to use them to solve logarithmic equations. So your homework that you'll be doing in class tomorrow is page 524, 12 through 20, all of them, and 33.